We've got a very quiet weather pattern in the U.S. on this Friday afternoon. Looking at the western U.S., very cool air mass persists over the Pacific Northwest, and you can see that temperatures in the high desert are mostly in the 70s. And that's pretty cool for this time of year. And then we find a weak frontal boundary running from western Wyoming into northern Nevada. Conditions are also on the mild side in California, where temperatures run from the 70s into the low 80s in the San Joaquin Valley. In Texas, we've seen some relief from the very humid, sultry conditions. Dew points have fallen off into the upper 60s to the low 70s, and that's down about 5 to 8 degrees from yesterday. What's causing that? Well, it's not apparent right now, but we'll try to investigate that in just a moment. The dry line itself is found mostly on the high plains down to West Texas. It's a very common position for midsummer. And then down there in Louisiana, little thunderstorm complex going on there, producing a cold pool across that state. And then up in Missouri, we find a very weak cold front, kind of a weak push of cold air coming out of the Great Lakes into Illinois and Indiana, bringing the temperatures down just a little bit into the upper 80s. And on the East Coast, we've still got a system off the coastal regions of New England, bringing a northwesterly component to the flow in New York City and Philadelphia. And you can see the temperatures there in Wilmington, Delaware, up to 96 right now. The reduction of the moisture is pretty obvious on this NAM forecast from yesterday. This is yesterday at 12Z. And if we run this forward, you can see the very high dew points there on the coast. These are 80s right here off of Houston and off of Corpus Christi. And then this purple band out in West Texas, I should say Central Texas, those are 70s. Now, bearing that in mind, let's run it forward in 3-hour intervals. By midday yesterday, there is some erosion of the moisture as mixing takes place that brings dry air down to the surface. And then by evening, a lot of 60s starting to show up through the I-35 corridor. Does the moisture build back in during the evening? Let's run that forward. There comes the moisture surge. Looks like upper 70s off of the Corpus Christi coast. And then those kind of die off, and you can see the moisture never really rebuilds. This is this morning here, 24-hour forecast. And if we pan the values over the map, you can see about 73 to 74, which is a little lower than what we've had recently. So once we get mixing once again, that's going to reduce those dew points even further, and you can see how they break up there. So what could be going on? Maybe a good product to look at would be precipitable water. Maybe the column as a whole is not very moist. So there's the precipitable water, and you can see that there's amounts over 2 inches through much of central and north Texas. If we run that forward from yesterday, looks like some dry air is infiltrating the Gulf Coast. Precipitable water's almost down to 1 inch. So when that advects up overnight, it'll come up in a very thin layer, but it'll mix out pretty quickly. And you can see that leaves us today with a lot of dry air. And there's the values that we're left with. There's the 70-degree isodrosotherm, the 65, and the 60. And then we'll throw in a 75. So the really rich moisture has really receded eastward. And then you can see the drier air just out to the west. Plenty of moisture, though, in Louisiana and Arkansas. Precipitable water over 2 inches there, and that's helping to support the thunderstorms in that region. Let's watch them build up using yesterday's run. There's the overnight hours. 12Z, that's this morning, and then we get the heating building in, and there they go. Now the 12Z run from yesterday, mostly focused on Arkansas and Louisiana. Let's see how that changed with the 0Z run last night. Run that forward. There's this morning, there's 9 a.m., there's noon, and there's 3 p.m. Okay, not really so big. Let's bring that up to 12Z. 18Z, 21Z, not a whole lot going on. Some stuff near Shreveport at 0Z. Let's try the high-resolution rapid refresh. And you can see it's a little bit more aggressive with the thunderstorm activity. And that shows you some of the difficulty that these mesoscale models have in forecasting this type of air mass thunderstorm development. The actual satellite picture, though, you can see some morning thunderstorms. This is going to be about 9:30 this morning. A couple of old storms there, and what looks like at first glance a worked over air mass. And if we run that forward, look at that vigorous thunderstorm development around Texarkana, down to Alexandria. So that's definitely some impressive convection in place, and we can see that the models kind of overdid, and we can see that the models really underdid that, especially the NAM. Did any models actually get that correct? The WRF ARW, that's a good model. It's got a very solid dynamical core. Let's run that forward. There's 11 a.m., noon, 1. Yeah, it does develop storms there, but not really all that vigorous. Not until late afternoon. The NISL WRF, we'll take a quick look at that. Ooh, that's a little more aggressive. 16Z, 17Z. Okay, that's impressive. And then we can see that little outflow boundary kind of pushes west into Texas and brings the storms into that area around evening. Okay, the WRF from NISL, that's going to be one to watch there. Let's try the European model. Okay, well, the first frame is going to be 18Z from the 12Z run. Looks like it's got that too far westward. And then 0Z, nothing. So European model did not do all that great. It actually does pretty well when there's well-defined outflow boundaries and fronts, but for this kind of air mass pop-up stuff, maybe not that great. And then we'll try the rapid refresh from 13Z. All we get is a national window there, and it really underdoes the activity. So we've completed a little bit of verification on that MCS in Louisiana, and there it is. Definitely some very vigorous convection. And you can see that outflow boundary shows up very well on the radar mosaic. Not much in the way of severe weather hazards in Louisiana, but we definitely have them up in the northern plains, North Dakota and Montana. So what's happening up there? Let's take a look. At this time, the radar not showing much of anything. Looks like one distant cell being captured by the Bismarck radar. Now the Minot radar is up there. Why is it not showing? I don't know. But we have visible imagery to the rescue. And what we see here, these look a little bit elevated. I can see the anvil kind of lofting to the east-northeast. This is the tail end right here. Some convective elements look pretty vigorous. Looks maybe a little bit mushy. And we can see that the moisture field out ahead of it is about non-existent. Now, if we animate this, we can see that the cells are mostly lifting to the northeast. But what we need to do is go a little bit further west. Now, a very common mode this time of year is for storms to form in the higher terrain out here in the mountains of Wyoming, out around Butte and Bozeman. And those can move out into the plains and get carried with the strong upper-level flow. Now you can see that we've already got towering cumulus and a lot of young cumulonimbus. So that may be indeed what we're looking at. And it looks like even the black hills may be trying to get in on some of this action. So just a quick check of the high-resolution rapid refresh panels. Let's bring this up to the 18Z run. And at this time, yeah, you can see it's got some convection going on the higher terrain. It becomes kind of widespread towards evening, south and southwest of Billings, out towards Broadus. And these cells just kind of move out into much of western Montana. So that's probably the place to be. And to really break this down further, we need to be looking at the dew point. This is really what gives you the key to what's happening. So this is probably one of the first products you should start with. And there we can see the moisture out onto the higher terrain of Montana. Yeah, you see this blue right here, that's going to be 60s. And then the medium greens, those are going to be 50s. So yeah, this is very dry air, and these are going to be kind of high-based. So it's kind of interesting as these storms get going, they drop these cold pools which bring moist air down to the surface instead of dry air. It's a little bit different. We're not really used to that in this part of the country, but indeed that's the case. Some 50s and 60s coming down to the surface, and the decapes are probably quite high. Let me back this up to just before convection develops. I'll drop a skew-t there, and you can look at the environment. And that's a classic inverted V right there. This is similar to what you see in Denver in summer. So some mid-level moisture right there, and that's given us our elevated parcels developing in that region. And then the decapes. Those are way up there, 1600, so these are going to be producing some pretty strong cold pools. Now the hodograph is elongated, and there's a tiny bit of curvature there. So there's some marginal severe weather potential, maybe a few rotating cells. I'm not sure about tornadoes or anything like that. You can see the 0 through 1 kilometer shear is very weak. So it's probably not quite that environment. You might get some land spouts, that kind of thing. But I would expect wind and maybe a little bit of hail to be the main risks. So let's look at the WRF solution, since that did pretty good. The Nissel WRF, run that forward. So there's 18, 19, 20Z. Storms going up in the Billings area and then moving out into the plains. So that's going to be pretty close to the interstate there. East central Montana, the best risk for a good storm. And then probably some more further back west. So it's going to be kind of disorganized, and then maybe this other cell out here on the edge may move into North Dakota after dark and start tapping some of that deeper moisture. Let me show that to you. Yeah, see how we got 60s right here and even 70s out in eastern North Dakota. So obviously as these storms move out into this region around evening with that upper level support, they may persist well into the nighttime hours. So maybe some overnight convection in this area. And let's see what the model is going for. So it's going to be about 6 p.m. Mountain Time, 7, and that storm, yeah, it starts intensifying and then moving towards the border. But just not quite enough support. Another cluster comes together about 2 or 3 in the morning. That looks pretty good. There may be a little bit of potential with that one. And then we get an MCS. And I'm sure that will definitely help the barley and corn in that area. These precipitation clusters are very important for the farming operations out there. And then the high-resolution rapid refresh. Clusters of storms, a little bit more aggressive, and those just kind of develop further overnight. And by tomorrow morning moves into Minnesota. So looking at the forecast skew-t from the high-resolution rapid refresh, around midnight, yeah, there's some decent moisture there. You can see it's not an inverted V. The environment is much different. Yeah, there is some elevated moisture, but the storms here have a good chance of becoming surface-based, and that's kind of what's happening there overnight. The astronomy calendar, remember that there is going to be an eclipse tomorrow night. That's going to start at about maybe 10 o'clock Central. It's going to be visible across all of North America. And you'll see just kind of a orangish red color to the moon. It's not going to disappear or anything like that, but it should be at least worth something looking at. And then our geography moment. The Sangre de Cristo Mountains. What is it and where is it? The Sangre de Cristo Mountains are in northern New Mexico, connecting into southern Colorado. And there's the location right there. So that runs from about west of Pueblo down to east of Santa Fe. And that connects up to the Front Range, which is the eastern edge of the Rockies. It's all part of the same basic range there. And that's an important air mass because it divides the mountainous plateau region from the Great Plains out to the east. And a lot of times during the wintertime, cold air masses will bank up against the foothills of the Sangre de Cristo. And you'll have, ironically, warm weather out in these valleys and very cold, frigid conditions out on the plains. Okay, that's about all I got for this evening. I appreciate you all watching. So we're coming up into the 4th of July weekend. Maybe some of you all will be barbecuing. I know we're going to try to drag the grill out. We haven't grilled anything in years, but we're gonna give it a try and clean out the cobwebs and the rust and stuff and get that going. I'm sure the weather will cooperate, and where you are, it likely will too. This is a very quiet weather pattern. And as for next week, we'll see the supporters on Monday and everybody else on Tuesday. And if you're not a supporter, here's our Patreon link. Your help is very much appreciated to keep these webcasts coming out. So if you can chip in a little bit, it would be much appreciated. Okay, everybody, have a great weekend. Bye-bye.